I've been doing some snooping around inside this HiWatt, trying to make sure I know everything I need to do before I order parts and stuff. And one of the first things I wanted to do was make sure that the jack situation was sorted. So I tried some different brand new Cliff mono jacks here, back where the speakers and effects loop stuff goes. And it was better than the old ones, which were totally worn out, but it still wasn't grabbing very well. So I found in my stash an Amphenol stereo, and the Amphenol stereo really grabs it well. There's no wobble. I mean, it's wobbling because the entire chassis is wobbling here, but that's a very secure connection. So all of these are going to get the Amphenol stereo. I'll show you that jack in just a second. Now, here's what that Amphenol looks like. This is the PC pen version rather than the through hole that I'll be using for this, but the rest of it's the same. And while we're using this in mono, we don't need the stereo for that. It's just one more little bit of metal grabbing on to the plug that goes into it, and that makes all the difference for those rear panel connections. And here's that same jack located on the front where it's going to go. And even with this switching Neutrik silent plug, it goes all the way in compared to the old mono Cliffs that wear out. So that's a no-brainer to install these, don't you think? And while looking around to figure out how this whole power section is wired, because I could tell that it was not wired anywhere close to the published schematic for the SA112 or to any other HiWatts I've seen. In fact, it has some mistakes in it, which I'll be discussing in just a minute. So I didn't know whether they had made a change, though not a great change, or whether this was a Friday amp or this was some dude in Modesto, California in 1986 saying dude way too much. It has some sloppy stuff in here. Look how long this screw is compared to these. This is not an original screw, but maybe that just fell out over the years and someone put that in there. But the wiring itself on these caps with the date code of 85 is not good for reasons I'll get into. But let's start with the grounds. You can see this bare metal wire attached to the ground of the IEC connector for your power cable. And that goes along the chassis here, kind of touching the chassis, but not really connected. And then goes up here, and then goes to this lug of the HT fuse. And that fuse for the HT is just on the HT center tap. That's that wire there. And then it goes again over here and goes to one of these lugs that you can't quite see, which is also where the cathode of this, in this case, KT77, though we're going to change to EL34s in this amp goes. And that puts your safety ground, which can have all kinds of hash on the line coming in, tied to the very noisy HT center tap ground, then going to something which is affecting your output tubes, and that's not a good way to do that. Also, the code is that the IEC safety ground should have its own connection to the chassis separate from everything else. That was not observed then, but that was the law then. This will be changed, so this will have a wire going to the chassis over here somewhere. There's a transformer there, so maybe over here. I'll find a place for it to be unobtrusive, but to have its own secure AC ground. And this wire can stay, but this wire is going away, and we're going to run this wire somewhere else on the chassis. The other noisiest ground in the amp is the reservoir cap negative, which is here. And it's fine if that's from the reservoir cap, but it's also tied to this stuff here used for screen. So we're going to be separating that, and this ground and the HT center tap ground will be tied together to chassis separate from all the preamp stuff. And all the preamp stuff will be grounded up here by the input jack. So this and all the screen stuff will all be going to ground here. There are a few other grounds in the amp like here that have not sorted out where they are and whether that's a good place for them to be or whether that needs to be tied back to the ground towards the preamp end of things. We'll get to that. In order to sort out which wires went where, I lifted this board up to look at the other side. By the way, this big 25 watt resistor is neither original nor necessary, so that's going to get changed out. But looking at the other side of this board, it has some truly terrible solder joints, just bare afterthoughts of solder there. These are not secure connections, and that goes across the entire board. That's terrible. These are broken, etc., etc. It just goes throughout. So in addition to changing electrolytics, I'll be reflowing everything on both boards and changing a few other things. Do you see the little metal shavings down here? Those are from me. These holes in the rear panel for the jacks were never made large enough for a standard jack. These things have a certain diameter. All the Cliff style jacks have the same diameter. And this is just a bit too small, so I slightly enlarged this one, which put these little bits of wire in there. I will not only make sure that all that's out of the amp, but I'm also going to go in here and deburr where I enlarged it. The factory stuff needed to be deburred, never was either, so all this will be improved as I go. Up top is the amp as it came in, and down below is the amp as it was on the schematic and as it was intended to be, which is a better design for a few reasons I'll get into. And I will be able to make a few improvements to the grounding in the process. Up top left, it's 100 microfarad in series with a 220 microfarad, and only the top capacitor has a bleeder resistor of 220K. That's your reservoir cap. Then it goes to a standby switch, and there it goes to HT1, which is the output transformer center tap. Then it goes to that 500 ohm, 5 watt resistor. And then we have HT2, which has got 200 microfarad, which is actually two 50 microfarad sections and a 100 microfarad section of two different multi-section capacitors in parallel. And that's got a 220K bleeder, and that goes to the junction of the reservoir, which is not correct for this, and introduces a lot of the noisy reservoir stuff, the poorly filtered signal, which still has a bit of ripple on it, back into the stuff that you thought you'd filtered. And then it goes through a 1K 2 watt to HT3 that feeds the reverb and the phase inverter. That's got 50 microfarads to ground. Then a 10K dropper going to the HT4, which is a different part of the preamp stuff. It's got a 20 microfarad, supposed to the 32 of the earlier amps. And then a 10K going to HT5, which is the first preamp stages. That's also got 20 microfarad versus the 16, which is more common in a HiWatt. I'll be changing this out to better match the original with some improvements. So 200 and 200 in series for total capacitance there of 100 microfarad on the reservoir. And both of them will have 220K bleeder resistors. And then HT2, you're going to have 50 microfarad with a bleeder resistor of 220K going to a 200 microfarad series connection, which will also have its own bleeder. And then HT3 has 50 microfarad there going to that same junction. Then 32 for HT4 and HT5. But the negatives of HT2 and HT3, which are joined in HT4 and HT5, will all be steered well away from those noisy reservoir and HT center tap grounds, and they'll go to ground at the chassis by the input. And that should make this thing behave an awful lot better than it does now. There is no published schematic for the output section of this particular model. I know that this 25 watt 1K is just in series with the two 5 watt 1K screen grids. So I do not think that this was, I know that this was not original. And I don't think 25 watts is necessary there. I imagine I'll probably use a 10 watt 1K or 470 ohm would be sufficient there. I will be replacing this 7 watt 500 ohm with a fresh one. Likewise, this 1K 2 watt dropper there. And this is a 91K in the bias supply. The schematic shows 110K. I'll order a 91K, a 110K, and 100K 2 watt metal film for that. It's got a standard 27K across the cap, the other side of this divider it's making. I expect that I'll play around with the value of that resistor bit to dial in the bias, or maybe I'll put in a bias trim pot, which this circuit lacks. Beyond that, unless we have any bad film caps, it's just going to be the electrolytics as discussed, and just as I go through, like I said, some of the other grounds, I'll be looking at where they are and where they might better be. But now that I've sorted out the weirdness of the power supply, and I know it needs to be addressed to make this thing quiet and to make, the jacks actually function correctly, I think we're on the right path here. Just going to be a lot of little ticky-tacky stuff that might possibly could have been done the first time at the factory. Maybe I asked too much. Anyway, thanks for watching.